Hi, my name is Samantha, and today we're going to be doing binary tree maximum path sum. This is a hard level LEETCODE question, and as you can see, it's sponsored in the DoorDash, Microsoft, and Amazon collections, and if I'm not mistaken, it's also in the Blind 75. This question is a really good question because there are different variations of it that can be asked, but the great thing is that if you know how to solve it algorithm-wise, you can answer the question in any of the ways that are thrown at you. So basically the question is given a binary tree, find the maximum path within that tree, where a path is the path between any, at minimum, two nodes. And this path does not have to go through the root. And the only thing to note is that the path cannot go back through a node once it's already gone through it, which we will talk about in example 2. But basically, in example 1, the answer is 6, and that's because 2 plus 1 plus 3 is 6. It's important to note that there are 3 different paths in this first tree. There's the 2 to the 1, the 1 to the 3, and the 2, 1, 3. And in this case, it uses the third path that I said, which is all 3 of them. And that's because all of the nodes are positive. So when we add them together, it's going to yield the greatest sum. However, if this 3 was actually a negative 3, then we wouldn't include it in our path. And our total path sum, or our greatest path sum, would be 3, which we get from the 2 plus 1. Example 2 is a little bit more complex. We see that the optimal path is 42, and that comes from the 15, the 20, and the 7. And so before we actually code it, let's just sketch a little so we can get a better idea of what's actually happening. And so this is the tree. We know that this 42 path comes from this little subtree, but I want to make a point that let's pretend that this root node wasn't negative 10 and it was 100. We would definitely want to include that in our path because it will yield the greatest path sum. And so if we were to have this 100, we would include the 9, we would include the 100, we would include the 20, and then from here, which one would we include? Because we can't include both. That's what I meant about you can't go to the 15 and then go back to the 20 and then hit the 7. We have to pick one of the sides. So in that case, we would pick the 15 because it's greater, and that would give us the greatest path sum. So I just wanted to show you that to make it clear that once we are at a node that has 2 children, we can only pick one of the paths coming from that side. And so that's important to note. That's, I think, the trickiest part of this question. So let's go ahead and just visualize this in a smaller scope and then zoom out. Let's start with the leaf nodes. And so when we're at this leaf by itself, the 9 is its greatest sum. Like when all we think that exists is the 9 by itself, 9 is our greatest path sum. So we're going to have a 9. And that gets sent up, which you'll see in a second. Now let's go to this other leaf node, the 15 and the 7. Same thing happens. It doesn't have a left, it doesn't have a right. So the maximum path, when we just are looking at in the scope of this 15, it's a 15, and same with the 7. We send up a 7. And so now let's, work our way up from the leaf nodes. So we would be at 20. And at 20, we say, okay, now we can have a path of our left plus our current plus our right. That is a path. And to be honest, that's actually the greatest path that we have seen so far because we've only seen a 9, a 15, and a 7. And so at every point, we are going to calculate what is the current node plus its left and plus its right. So in this case, we get a 42. So that needs to be recorded somewhere. But then when we send something up from the tree, we can only send up one side. So which side are we going to send up? We're going to send up this path, which is going to be the 15 plus the 20. So we would send up a 35. And so then we would calculate this negative 10 and in that case, it would be 34, which would be the result, because it would be the left side plus the current node plus the right side. But we have to record somewhere that this 42 was the greatest sum that we ever saw. So just because it's not at the root doesn't mean anything. And so I hope that gave you a little bit of visualization of what we do. The important thing is that whatever we send up the tree is just the left or right side plus the current, but we do somewhere in our algorithm have to record the subtree that makes up the node plus its left and right. So now when we go back to code, so as you know, with tree questions, you always, if not root, I think maybe return -1. And then I always like to do helper functions. It's going to take in a tree node. Actually, let's make an int. And then, so we're going to call this helper function on our root. And then we're just going to return answer, which I like to have as a global answer. And originally, let's set it to 0, I guess. We can get back to that. And so basically what we're going to do is we're going to traverse all the way down, left, 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 right, 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 so that way we can get to our leaf nodes. So we're going to say if not root. I will get back to this so you guys can like visualize this. Otherwise, we're going to call helper on roots left, helper on roots right. This returns an integer, so we're going to say int L, int R. And then this is the important part. So answer is equal to the max of any answer we have previously seen and L plus R plus our root value. And then we are going to return ... We'll get to that. And so if not root, so let's visualize this. We send this helper function in on this -10. It is not empty. So we're going to call it on left. So now this recursive function starts over. And now our root is 9. And we're going to say if not root, that doesn't execute because this root does exist, right? So now we're going to call the helper on roots left, which is a null pointer. So if we're at a null pointer, what do we want to return? We want to return a 0 to indicate that the left doesn't have a path, right? So we're going to return 0. And so then we come back to the stack call of when our root is 9. We have just executed this and we have an answer, we have a value for our left, which is 0. Now we're going to call it on 9's right. The same thing is going to happen. That's going to become a 0. So now we can come to this line where we say our answer is the max of our previous answer, which is 0, and our L plus R plus root val, which is 0 plus 0 plus 9. So now when we are at this node, our maximum path is 9. And that is good. That's exactly what we're talking about in the smaller scope. And so now we return what? We have to return something up. And this isn't going to make so much sense. So let's go into the scope of here. Let's fast forward. So say we get to the 20 and then we call left on 20. So that gives us the 15. And then we call left on 15, it gives us the 0, right on 15. So we're going to return a 15 up here, and then we're going to have the 7 here. And so what I was saying is that we have to return. So when we're at the 20 and we need to return something up, we are going to return the max of root val plus L and root val plus right. Because this will show that when we're sending this up, it's going to be the max of 35 or 27. And so that is how you do this question. There is one final tweak, which is there are some test cases that you will encounter when you submit this, that there are negative node values. And if that's the case, we do the max of that calculated answer and 0, just to ensure that if something is super negative, we're just not going to include it. You can go through the test cases, or you can even run this code without the max just to see which ones fail so you can see the tree. But this is how you do the question. Super clean, super simple. The complexity is O of n, where n is the number of nodes in the tree. And like I said earlier, there are many variations. So in this case, we were just asked the total sum, but it might be the case that you're asked, what is the path? Like what are the nodes that are included in this optimal sum? So that's just like one of the things that you can do it. They might give you a question, they might give you a target node where you have to determine if there is a path such that it equals the target value. So there are many different variations of this question, but this is how you solve it. And let's hit submit. Silly mistake. We are not going to set our original answer to 0. It's int min. We're trying to find the max of it. Silly mistake. That's because in this case, if it's -3, -3 is our greatest value. It is still greater than int min. Let's submit that. And we see that it passes. That is how you do this question. Thanks for watching.